Hello students, welcome back to third session of your physics marathon part. So we'll be continuing with the discussion of your AIATS plus phase 2, and this is your mock test happened on 9th of March. So this is mock test number 8. So this session revolves around these topics. So these prime topics are laws of motion, work, energy and power, gravitation, mechanical properties of solids, atoms and nuclei. So this session primarily will focus on the numericals or the questions which you people have committed wrong from these particular areas or chapters of physics. So let's move on. Let's start with the discussion. Now the very first question says, the position of a body of mass 1 kg varies according to the law. And this law is, this is basically xt. Xt stands for position is a function of time, is equal to AT plus BT square, where A is 5 meter per second and B is 2 meter per second. The force acting on the body at t equal to 2 seconds is. Now x is given to you as AT plus BT square, where A is 5 meter per second. No doubt A is a constant. So this is how position varies with time, but A is a constant. Don't get surprised with the numerical units assigned to it, and this is meter per second. And the value of B is 2 meter per second square. No doubt B also has a constant value, but why these units are assigned to it? So let's understand the very first concept, why these constants, they have units of A as meter per second and B as meter per second square. So this is based on basically your homogeneous rule. And you know, this homogeneous rule clearly says the dimensions of x and AT has to be same. So x, that represents the position. So I mean, like x is basically the standardized notation for position. So this position has units as meter and t as time in seconds. So what is the unit for A? So that becomes meter per second. So that qualifies your first concept, A being a numerical constant, no doubt about that. But does it have units? Yes, it does have, and the units for A are meter per second. So this is the very first. Now for the B, simultaneously x should also be equal to BT square. So this is as usual in meters and time being in seconds. So the unit wise, this is meter per second square. So very first doubt, why we have units for these constants. So we got the answer for that. Now, so if I write down this concept, this equation again as 5t plus B as numerically 2 t square. So this is your equation. So we have rewritten that equation. So now you see A has been assigned a value as numerical value as 5 with units, and units are defined to you as meter per second, and B is numerically assigned a value of 2, and unit wise this is also meter per second square. So this is the equation, this is the relation we have. Now we have to find out, so this is basically position versus time, and we have to find out force using this relation. So what you know about force, how you approach, what you know about force is just put it down there as the very first step. So force, that is required expression we are looking for, is m into a. This is the required expression. Now mass is no doubt given to us as 1 kg. So it means if you have a, then you can answer this question very well. So any one of you having any idea how we'll obtain the value of a from this position versus time equation? Anyone? Okay. So we know if you differentiate this position with respect to time, what you will end up with? Instantaneous velocity, and this expression will get reduced to this one. So this is how velocity varies with this time. But we have to reach the acceleration part. So dv by dt is your acceleration, and this becomes, the derivative of 5 is 0, 4t becomes 4. So acceleration is 4 and unit wise meter per second square only. So we got the expression for the acceleration. So now we were supposed to find out the force. So force is mass into acceleration. So mass being 1 kg, acceleration is your 4 meter per second square. So the numerical value of the force will become 4 Newton. So do we have an option? Yes. What is the significance of this then? Is this a uniform accelerated motion? Yes. This is uniform accelerated motion. No doubt about that. Constant acceleration. But let's suppose let's write down the equation for x again as maybe 5t square plus 2t cube for the same mass 1 kg. We are supposed to find out force at time t equal to 2 seconds. So this is another problem I am giving you. So I request you, if you can spend a minute to give me the answer for this force, keeping the mass same as 1 kg and time again being at 2 seconds. So please make an attempt. Okay, so how you will go for it? So dx by dt, what you will end up with? Velocity? Yes or no? So what it becomes? 10t plus 3t square. And your dv by dt will define the acceleration. So what the acceleration becomes? 10 plus 60. So your acceleration is 10 plus 60. Now look at this. Acceleration is a function of t. So with every change in value of t, you will have a different value of a. That means acceleration is what? Is it a constant or is it a variable one now? So when acceleration is a function of t, so this is your variable, or the other name given to it is non-uniform accelerated motion I am defining it as completely. So at time t equal to 2 seconds. So for time 2 seconds, so this becomes 22 meter per second square. And you were supposed to find out the force at 2 seconds. So force is again m into a only. It means m being 1 kg and acceleration at 2 seconds is 22 meter per second square. So that gives me the value of force as 22 newtons only. So this is how, I mean, like, you have to develop a relation, you have to develop an approach to solve these kind of questions. So the contrasting difference between these two examples, one was your actual question where you had constant acceleration, and in the second situation where acceleration is a variable one. So for the variable one, the value of force would be different at different instants of time. Any doubt from this part? Any doubt? If you have any doubt, please confirm your doubt, please. So Pankaj is there, Kumaran, Abhinav Kumar Maurya is there, Sadaf is there. So everyone, good morning, good afternoon. I hope you all are preparing well for your NEET. So if you have any doubt, please confirm, ask your doubt, or shall we move then? Okay, fine. So I'm moving to the next question. Next question is again an interesting question. So let's understand it from the statement first. A stationary boat having a mass of 4m at the surface of a pond, and if a man of mass m jumps out from the boat with velocity v, then velocity of boat after jumping is. Now first we need to understand, we need to shortlist from which area or which concept is involved in such kind of numerical problems. So as the problem clearly reflects or suggests you, so this is, there is no external force acting on the system. When I am saying system, so system involves your boat that is of mass 4m and a man is on boat that is of mass m. So there is no external force involved. Man has now jumped out of this. So first, when there is no external force, so when you have external force as 0, it means your definition clearly says when this external force is 0, this is the net external force, there is no external force. So if this is 0, so it means momentum of the system remains constant. So this is purely based on your concept of law of conservation of linear momentum. So now once you have identified the area or the part of physics, chapter of physics, topic of physics, then it would be easy for you to approach for all the conceptual or numerical situation that is from this area. So let's build up. So first we will try to solve this concept, this numerical situation. Then I will help you to build up with one or two more numerical situations. So what other common numerical problems you may find from these kind of, like situational physics. So this is based on the law of conservation of linear momentum we have. So stationary boat. So you have a boat of mass 4m and this definitely man is there of mass m. So initially they are at rest. So what is the initial momentum of the system? So initial momentum of the system is 0 because boat carrying a man is at rest. So initial momentum is definitely 0. But now let's suppose man jumps from the boat with some speed v. So what is the final momentum of the system? What is the final momentum? So this is m into v. So this v is basically for the man, and because this is based on law of conservation, so your initial momentum has to be equal to your final momentum. So just to conserve that momentum, just to maintain that momentum as 0, definitely boat will be pushed off. The moment you jump, the boat will move backward. So this is mass of the boat, and let's suppose this is the velocity. So this is capital V. I am keeping this velocity as capital V. So initial momentum has to be equal to final momentum. So mv is equal to 4m into v with a negative sign, and this negative sign is a condition for the conservation of momentum. It means if man is jumping out towards this side, towards left side, then boat will be drifted slightly towards the right side, so that momentum of the system will remain same. And negative sign clearly implies that opposite effect. So this goes with this. So what we have to find it out, velocity of the boat. So velocity of the boat will be v by 4, and definitely negative sign implies the opposite effect. So what is the answer for this? So this velocity is v, so this is minus v by 4. That is the correct explanation we had, or we have it for this numerical situation. I hope you people have understood it well. Any doubt from this part, you please be comfortable and can clear your doubt. Anything from this section particularly? Or give me a chance to explain it further with one more numerical situation, if you allow me. So shall we move? Shall we? Okay, so I'll build up one numerical situation, and this is a very famous PYQ, what I'll be discussing it with you right now on screen. So shall we? Fine. So I'm taking one example to build up this situation more, and the example I'm discussing on board right now, and that is the actual PYQ from your previous year questions. So this is one of the important concepts. So let's understand a projectile situation. So let's suppose you take one particle, right? And this particle is projected with speed u at an angle theta. You got it? At its highest point, so this is the highest point. At this highest point, this is split, or this is broken into, let's suppose, 3 pieces, and ratio is 1:1:2. Just try to follow the example. So we have projected a particle, and now, because to keep this ratio, shall I say initial mass projected at speed u at an angle theta? I am taking it as 4u. So that is the initial mass of the particle. And initial mass at its highest position is moving along this direction, u cos theta. I think this situation, this is clear to everyone. So what is the initial momentum? I'm not saying anything else, I'm just asking for initial momentum. Initial momentum is momentum of the particle at its highest point before it just splits. So mass we have assumed as 4m. So this is the mass and speed is u cos theta. It's the horizontal speed your projectile possesses at its highest point. So this is the initial momentum. So this much situation is clear to everyone. So shall I? Now listen to the question further. This first particle just drops. So this mass m just drops. So its speed is 0. The other particle retraces its path. So this particle m retraces, so it continues to follow the same path. So possible only when it is following in the opposite direction. So we have to find out the speed of this part. You got the situation? You got it? So I'm just giving you the statement again. So a projectile of mass 4m projected with speed u at an angle theta. At its highest point, it splits into 3 pieces such that the ratio of these 3 mass wise, this ratio is 1:1:2, right? And this ratio has suggested you to define the initial mass as 4m, such that the first particle just drops. The second particle retraces its path. Retraces means minus u cos theta. What is the speed of the other particle? And the other particle is of mass 2m. I think now everyone is clear about the situation. We have built it up. So it means first, if there is any doubt, I would like to clear your doubt first. So first important point to be noted, when particle splits or this burst or it breaks, no external force has been applied on the particle, and it is purely because of the internal forces particle has splitted. So it means if there is no external force, so no external force, it means we are again in a condition when there is no external force, momentum of the system remains constant and will follow the law of conservation. I am writing conservation as abbreviated form, conservation of linear momentum. So it means initial momentum has to be equal to what? Final momentum. Initial momentum, which momentum you are talking about? Are you talking about the momentum with which it is projected? No. We are talking about momentum when it is at its highest position. So what is the momentum? 4m is the mass, u cos theta is the speed. So 4m u cos theta is the initial momentum of the particle at its highest position. You got it? It has to be equal to. Now first of all, the particle of mass 4m is split into 3 pieces. One mass falls freely. It splits and drops like this. So carrying no momentum at that point. So its contribution is 0. But what about this one? Its momentum is m, mass into its speed, u cos theta. I would like to highlight again why we have taken it as minus u cos theta, because the question was stated as it retraces its path. When you say it retraces its path, it's possible only when you do it with the opposite sign and with the same speed, that is minus u cos theta. And there is one more particle left, and this is of mass 2m with speed v, and it is this v that you are supposed to find it out. So it is this v that you are supposed to find it out. So now we have built up the situation to understand this concept very well. So if you have any doubt, then you can ask me from this section at least, from this numerical section at least, or shall we move? Fine. So this goes 4u cos theta, and this u cos theta will give you, this is what? Basically 5u cos theta, and here we have 2v. So we got the speed with which the third piece, the heaviest piece 2m, will continue to move along this direction only. Why? Because again you have to maintain your law of conservation of momentum. I hope we got the situation very well, and this is so overall this question is actually from your PYQ part and based on the same concept of law of conservation of your linear momentum. That is why I have picked up this situation so that I can make you understand to solve these kind of numericals. Any doubt? Any doubt? You can please confirm your doubts. So if there is no doubt, so I think we should move on. So I am moving on to the next situation. Yes. So next situation, next numerical is there on the screen. So please, hi Dashrath, why you have joined so late? It's been almost more than 30 minutes. We have started this class. Okay, no issue, please. Two perfectly elastic objects A and B of identical mass. So mass of A and mass of B are identical. They are moving with velocities 15 meter per second and 10 meter per second respectively. So velocity of A is 15 meter per second, velocity of B is 10 meter per second. So this is the situation we have. So this is the numerical data. So in case study class, why we consider only two mass momentum and final momentum? I think you missed out the explanation. Dear, that particle was dropped. So that is why we dropped the momentum of that, because its initial speed, the moment it splitted out and it just dropped. So that is why we took it as zero momentum contribution from the second part. So now you please focus on this one. So initially we had masses, same masses. They are moving with speed 15 meter and 10 meter per second respectively. Collide along the line joining their centers. Their velocities after collision are respectively. So they are colliding and their velocities of collision respectively. So based on conservation of linear momentum, right? So these are perfectly elastic. This is point to be noted. Now conservation of linear momentum says MA UA plus MB UB is equal to MA VA plus MB VB. You got it? And masses remain same. So these masses will go. So VA plus VB is what? UA and UB. So this is 15 plus 10, 25. This is the first expression. Got it? Now we have to understand perfectly elastic collision. For perfectly elastic collision, do we have an idea about coefficient of restitution as E? So coefficient of restitution as E. So for the perfectly elastic collision, this is 1. For perfectly elastic collision, the value of E is 1, and for perfectly inelastic collision, we'll take E as 0, and for the real life situation, just for your understanding, this is 1, 0 to 1, that is for the real life situations. Mukesh Kumar Mishra has just joined. Good afternoon. Good afternoon, dear. So conservation of linear momentum, and now we have introduced the concept of restitution. Now definition of coefficient of restitution says, so this is basically you are defined as ratio. A ratio of what? What is this ratio is? So this is ratio of velocity of separation to velocity of approach. So basically this coefficient of restitution is understood as what? Coefficient of restitution is defined as ratio. So when you are defining it as a ratio, so it has just numerical value, no units, no dimension. So what is the velocity of separation we have? Shall I call it as VB minus VA? And what is the velocity of approach? That is before collision, and velocity of separation is after collision. So velocity of approach, shall I call it as UA minus UB, and because this is for the perfectly elastic bodies, this is for perfectly elastic bodies, so this is taken as 1. Now let's put the values. So VB minus VA, and when you put the values, VB minus VA by UA was 15 and UB is what? UB is 10. So this becomes 5. So VB minus VA becomes 5. So I hope you got this expression, Vb minus Va. You have understood it, how we got the second expression. Because this equation, law of conservation of momentum, no doubt this is applicable to all the types of collisions, be it elastic or inelastic, but it involves two variables, Va and Vb. So we got the first equation, Va plus Vb as 15, but where is the second equation? Because this is a two variable problem, two linear variables are involved, so it means you have to have that second equation so that you can solve these two equations. So second equation is Vb plus Va is equal to 25, and when you take, so Vb becomes 15, and when it is 15, so what is this? It becomes 10 meter per second. So any doubt from this part, how we got it? So this is one way of approaching this numerical, one way of approaching. You got it or not? Interesting point. Have you ever noticed one interesting situation? UA is 15, but the final speed of the second particle, Vb, becomes 15. This is UB was 10. Now, this is the final speed of the particle A. So what you have observed, a very interesting relation has come to our notice. They have exchanged their speed, and this is possible because the collision is elastic. Had it been the inelastic collision, then this possibility would not be there. So I think we have noticed one very interesting concept also in this numerical situation, velocity interchange. So this is very fine concept. Good. Or do you have any other approach to solve this one? Shall I give you one more formula? Okay, fine. I am giving you. So let's assume you have particle m1 moving with speed u1. You have another particle m2 moving with speed u2. And this is the situation before collision. After collision, this mass will have speed v1 along the same line of direction, and the other mass m2 will have speed v2. You got it? And we are assuming it as elastic collision. This is also important point to be noted. This is elastic collision, and elastic collision follows law of conservation of linear momentum and it also follows one more basic concept, that is law of conservation of kinetic energy. That means kinetic energy before collision and kinetic energy after collision will also be same for elastic collision. So then you have law of conservation of kinetic energy. So as per the very first law, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. And for this situation, you have half m1 u1 square, that is the initial kinetic energy before collision, is equal to, this is v So initial kinetic energy is also equal to final kinetic energy of the system, that is before collision and after collision. And when you solve these two, V1 becomes yes. So these are the fine expressions will obtain after solving these two, right? And these two formulas will be your master formulas. You can solve rest of the numericals using these two concepts. So let's apply the same velocities for the given situation, and the given situation was m1 and m2 was equal. So let's take it as m. u1 was given to you as 15 meter per second and u2 was known to us as 10 meter per second, and we were supposed to find out v1 and v2. So this was the situation. Now let's apply this situation. So when you find out v1, this part goes. So 2 m2 is again m. What is u2? u2 is 10. And m1 plus m2 will also give you 2m. Similarly, when you do it for this v2, this part goes. So this is 2, m1 is also m, u1 is 15, and m1 plus m2 is also 2m, and this is 15. See, the very same interesting relation we are getting it using the same shortcut formulas also. Velocity interchange that you observed. But I would like to add on one more thing. This is possible when you have a elastic, perfectly elastic collision for this situation. You got it or not? So this is the second case when you have this one. This is the second way rather. I hope you people have understood it well. Still, if you have any doubt, you can ask me here only, or shall I move? Fine. So we are moving to the next. At what height from the surface of Earth, okay, the total energy of a satellite is equal to its potential energy at a height of 3r from the surface of Earth. So first you read the statement well, understand it, then put the numerical value to solve it like this. So first we have two concepts, potential energy and total energy. Got it or not? So let's define the potential energy. So this is negative minus gm, mass of Earth or planet, and small m is the mass of the satellite, and this is h plus r. And potential energy is defined at a height of 3r. So minus g m. So when you put the value of h as 3r, 3r plus r will become 4r. So this is the potential energy as per the given statement. Now let's understand the total energy of the satellite. So total energy of the satellite at what height? So total energy of the satellite has to be a generalized concept in terms of height. So this is also negative. Interesting point. Total energy has to be negative if it is within the field. So this is also minus gmm by 2, and this is r plus h, because this height is not given to us, and rather this is the main question. So they have asked you to give me the value of this h. But they are saying this is equal to this energy. So let's equate these two expressions. So this part goes with this negative goes with this goes with this, and H plus R is 2R, so H is equal to R. So H is equal to R is the required height at which the potential energy at a height of 3R becomes equal to total energy. You got the situation? Any doubt? You can ask me. Let's move on to the next. The orbital velocity of a satellite of mass m around Earth is proportional to. It's quite easy. So what is the expression for the orbital velocity? Can any one of you give me the numerical value of this? Either you can put it like this, gm by r, or root gr. Satellite of mass m. Do we have any small m, any variable there as small m? Does it depend on the mass of the satellite? This is radius of Earth, let's suppose. This is mass of Earth. If we are talking about, like the satellite around Earth. So this is mass of Earth, this is radius of Earth. Does it depend on the mass of the body, mass of the satellite? Not at all. So there is no variation. First option, a clear winner in the very first shot. Any doubt from this part? Okay. So shall I move to the next? The correct SI unit of bulk modulus B among the given options is bulk modulus. So this is bulk modulus of elasticity. How you define bulk modulus? So this is defined as ratio normal stress to volumetric strain. And we know normal stress is force per unit area. I am talking about not the expression here. So we'll be discussing first the units, and volumetric strain is unitless, dimensionless. So if you talk in terms of units only, so it has to be Newton per meter square only. So this is the correct option we have. You got it or not? And if I ask you the dimensional formula, so the dimensional formula is MLT minus 2, which is same as that of even Young's modulus, your pressure, and one more, that is modulus of rigidity. So they all have the same dimensional formula. So look at this concept. So you need to satisfy yourself in terms of your answer, that is Newton per meter square. So they are talking about only the SI units. Otherwise, bulk modulus, if you go and solve it, this is the complete expression for the bulk modulus, and it is defined for solids, liquids, as well as gases. So this bulk modulus is defined for all the three states we have. Got it? Any doubt? Energy required for the electron excitation in lithium plus plus from the first to the third Bohr orbit is lithium plus plus. So first, hydrogen atom. So this expression for the energy level of the nth orbit is minus 13.6 electron volt by n square. But for hydrogen like, this expression becomes Z is there. What does this Z means? Atomic number. So you are talking about lithium plus plus, so this Z is 3. So for the lithium particularly, this energy expression becomes So this is the required expression. Now we have to find out energy difference from first to third. So that is energy difference from first to third. So when you move from first to third, you will absorb, and when you jump from third to first, you will release. But the amount of energy involved during the absorption or the emission will remain same. So when you take the difference, what this difference is? What is E1? So because this is minus, so that becomes so this numerical difference will be the answer, and when you solve it, it gives you 108.8 unit wise remains same as 108.8 electron volt only. So it's quite easy, quite interesting. Any doubt from this? So Kumaran understood it. Okay, so I'm moving ahead. The mean density of a nucleus of mass number A is proportional to, very important, and it has been asked number of times. So first you understand, so when you write down mean density, so this is mass of the nucleus divided by volume. Got it? So mass of the nucleus is mass number, that is the number of particles within the nucleus, and mass of one nucleon. So I am putting mass of one nucleon. Nucleon involves your proton as well as neutron, so that is small m. And volume wise 4 by 3 pi r cube. So this is the expression. So this A is there, m is there, so we'll take 3 on the upper side, 4 pi. Important point, how the radius size varies. So r is basically r naught a power 1 by 3. This is how the size varies. So when you take the cube, and this r naught is constant of the order of 10 to the power minus 15. This goes with this. So this is fixed, 4 pi is fixed, 3 is fixed, mass of nucleon. If I'll give you precisely the mass of nucleon, basically this is the mass of what? Either your proton or neutron. So that is also fixed, and mass of proton or neutron is taken as same. So this density is primarily constant, and this is of the order of 10 to the power 17 kg per cubic meter. Got it? So question is proportional to. What is this proportional to? It's not proportional to anything, it's a constant. Got it? So this is all from my side, and myself, Puneet Kathuria, your physics faculty. Thanks you all for attending this session. So you keep asking your doubts in the next sessions. Till then, goodbye. Take care. Thank you.